We will be considering the stoichiometry calculations, including limiting reactant for the reaction of solid copper and aqueous silver nitrate. And those will form solid silver and aqueous copper 2 nitrate. That is what is classified as a single replacement reaction, where copper started off as neutral atoms and ends up as charged ions. And silver starts off as charged ions in the ionic compound of silver nitrate and ends up as neutral atoms of solid silver. In this question, we want to know how many grams of silver will be produced from 5 grams of copper and 1.00 grams of silver nitrate. So the first thing we do is we identify the given information, and then we are going to write the given information over the correct substance in the balanced chemical equation. This is the key step to success in AP chemistry problems. If we have 5.00 grams of copper, we go to where copper is in the balanced chemical equation. We literally are just writing 5.00 grams over top of that. Same thing for the silver nitrate. And then we're identifying what we are solving for. So we want to know grams of silver. So we put a question mark over silver to identify that's our unknown, and that we want to end up in the units of grams. So this is just directing our attention to the correct thing. So now we are able to see that we have 2 possible starting points, right? We have 2 pieces of given information, and we need to consider those separately. We want to know how many grams of silver are going to be produced, and we don't know, though, which reactant will run out first, or do we have them in the exact correct amounts that we have stoichiometric ratios, right? Stoichiometric amounts, which means we have just the right amount so that they both run out at the same time. Unusual, but possible. Okay, so that means that we're going to start off by just doing our 5 grams of copper. That's our first starting point. We're going to completely ignore the silver nitrate for now, and we're going to go from 5 grams of copper all the way to grams of silver. So our first thing we do is we write the given information, 5.00 grams of copper, and we put that over 1. That is our given information. It needs to be given in the problem. It needs to be something, we always start off with something that you can measure in lab. So you get grams. Okay, I have a balance. I could measure that. Or milliliters would be something that you can measure easily in lab. You're usually not going to start with something like moles because, I don't have a mole measuring device, right? So usually grams or milliliters is a great place to start. Okay, and then our next thing is we need to go from we need to get rid of the grams of copper, and so we are going to put grams of copper on the bottom, and we're going to go to, which is moles of copper. We need to go from one substance to another on the balanced chemical equation. That means that we need to be in moles to be able to do that. You can't go from one substance to another unless you are in moles, because moles has to do with how many particles, and the balanced chemical equation is based on how many particles, right? 1 copper atom goes with 2 will produce 2 silver atoms in the final reaction, like they are in a 1-to-2 ratio of particles, not a ratio of mass, right? The coefficients of the balanced chemical equation aren't telling us the mass of the substance. It's telling us the number of atoms or the number of particles or the number of, we're just going to scale that up to moles. So your first goal is to get to moles so that you can switch substances. So we can stop talking about copper and start talking about silver. Always write the unit and the substance and then go back and fill in the numbers. So we know we need to get rid of grams so they're in the bottom. We need to go to moles so they're in the top. How do we know about grams and moles going together? Well, we know molar mass, which is the mass in grams of 1 mole. So we put a 1 in front of moles, and we put the molar mass of copper in front of that. Okay, next conversion factor. Now we're in moles of copper. Now we're ready to switch substances. So we got to put moles of copper in the bottom, and now we need to put moles of silver in the top. Now we need a true fact that we can put in here for the coefficients of the in front of the moles, and the way we do that is the coefficients of the balanced chemical equation. That 1 unwritten 1 mole of copper is going to form 2 moles of silver. We get that from the balanced chemical equation. Your equation needs to be balanced. Now we are ready to get rid of moles of silver, and now we go to the thing that we want, which is grams of silver. We know how those go together. That's just molar mass again. So we put our molar mass in there, we do the math, we can make sure that our units go away. The only unit that doesn't go away, because moles of silver divided by moles of silver is 1, those go away. The only unit that doesn't go away is grams of silver. And so our calculator is going to show us a bunch of things there. We need 3 significant figures. Because the 5.00 is 3 significant figures, so that means that we need to round that. The 1 stays, the tens place, the units place, and then we're going to need the tenths place. But the fact that the number after the 9 in the tenths place is 5 or greater means we need to round that 9 up to essentially a 10. So that makes that 17.0 grams of silver. Okay, that may or may not be how many grams of silver are actually produced. That's how many grams of silver would be produced if every single bit of the 5 grams of copper reacts. We don't know if that's possible yet. We need to figure out for our 1 gram of silver nitrate, what if that runs out first? So it's kind of like a hypothetical hypothetical question here. How much silver could I make if I use up all my silver nitrate? Okay, so once again, we start with given information. We get rid of the grams because grams on the top, grams on the bottom. We want to go to moles. This is just going to be molar mass again. So we calculate our molar mass from periodic table. Periodic table always available to you. Now we're in moles of silver nitrate. We want to not talk about silver nitrate. We want to talk about silver. So we get rid of our moles of silver nitrate. We go to moles of silver. Coefficient of the balanced chemical equation tells us what to put there. 2 silver nitrates for every make 2 silver atoms. And now we're going to get rid of moles of silver and go to grams of silver again. We already knew that conversion factor because we just did it. Okay, so once again, our calculator is going to show us stuff. You don't have to show me all those extra digits, just your final answer is fine. 3 significant figures. Once again, we're going to have to round for that third significant figure. That'll make that 0.635 grams of silver. Okay, we are not making both 17 grams of silver and 0.635 grams of silver. We're going to make whichever amount is less, right? So we think of this as I have enough copper to make 17 grams of silver, but I only have enough silver nitrate to make 0.635 grams of silver. And so that means that I am only going to be able to make 0.635 grams of silver. That's how much will actually be produced because I can't make 17 grams of silver because I don't have enough silver nitrate for that. Once I'm out of silver nitrate, I'm not making any more silver. So silver nitrate is the limiting reactant and copper is the excess reactant. And then in blue here, I'm just showing that each of these steps in the conversion factors has a reason, right? We have a reason for stating each of these, right? So that's the last one is molar mass. Okay, so we have given information that's going to be stated in the problem. Molar mass, okay, we know how to do that. Mole-mole ratio, that is a true fact for that balanced chemical equation, and then molar mass again. So we know the limiting reactant and we know how much will be produced, and we also can identify the excess reactant. When this reaction is all finished, there will still be copper, solid copper sitting in the bottom of the beaker or whatever it is, because we didn't use it all up, right? We only had to use up enough to make the 0.635 grams of silver, and so there's going to be extra. That's why it's called excess reactant. Okay, so another option for what can happen here is that you are going to make that your given information might be telling you about a solution. So you might not have, if you have a solid reactant, it'll tell you how many grams, right? Possibly moles, but usually grams. If, however, you're given your information in terms of concentration, then you just need to use, you need to make molarity into a conversion factor. So we're just going to use kind of the same balanced chemical equation here, but our given information, let's instead say that we were told not how many grams of silver nitrate were dissolved, but instead that we had 39.2, that should say milliliters, I will fix it here, of 0.15 molar silver nitrate is used. Okay, so that's your given information. So that means you're going to write both of those things over. There is the over the substance in the balanced chemical equation. We know 2 pieces of information about the silver nitrate solution. We know the volume, like you could measure that with a graduated cylinder, and we know the concentration. So which one of these are we going to use? And we again want to find how much silver nitrate. The two pieces of information for silver nitrate, we're going to use milliliters to start this off, because milliliters is something I can measure out in lab. You are not going to start with molarity. Do not start with molarity. Start with the thing you could measure in a lab, which would be volume. Okay, so that's your given information. The first task is to go milliliters to liters. That is just true. That's how many milliliters are in a liter. And we need to be liters because our definition of molarity is moles of solute per liter, not milliliter, of solution. So that's our next thing, is we're going to go from liter of silver nitrate solution to how many moles of silver nitrate. So again, that would mean how many particles of silver nitrate, which of course we know that would be separate, right? You'd have silver ions separate from nitrate polyatomic ions in the solution. They are not joined up. And now we're ready to, now it'll look just like what's on the previous slide, right? We're going to go from moles of silver nitrate to moles of silver. We've got coefficients of the balanced chemical equation for that. And then we're just going to use molar mass to get to grams. And we're going to do the rounding, and that'll tell us how much silver nitrate can get made. Given information, true fact, I mean, that's just true. There are 1,000 milliliters in a liter. That's how the SI system is set up. Now, this is the one that's kind of new here, is your molarity. It is true that 0.15 capital M molar, that's how we'd say that. So when it says up in the highlighted pink, 0.15 molar is how you need to say that verbally or in your head. Capital M, you pronounce that as molar. That's telling you the concentration is 0.15 moles of that solute for every liter of solution. So that means that you can write molarity as a conversion factor, because all you need is a fraction, right? Is a ratio, is a relationship between what's in the numerator and what's in the denominator. In our case, we need the liters to be in the bottom because those are the units we're trying to get rid of. But if you needed to get rid of moles, you would just write the reciprocal of that relationship. It is true, if there's 0.15 moles on the top and 1 liter in the bottom for a 0.15 molar, it is also true that 1 liter in the top would match up with 0.15 moles in the bottom. It's just that's how that goes together. That is true for that that molarity. And then you just have your mole-mole ratio again and molar mass for the last one. So when you're doing conversion factors, write them out. This is the key to success. It's going to be organized for you and for me. I can easily follow your work. The people grading your AP exams will be able to easily understand what you did, and you won't lose track of things, and you don't have to okay, I think it's multiply, or I don't know, maybe I divide, or let me go do this calculation and then put this number over here. Keeps everything nice and organized and logical, which is helpful. Alrighty, that is the end.